Hello everyone, welcome to yet more overflow sessions of API review, where today we started with a pure vision of we were going to get through the analyzer's backlog, but we have a blocking thing that we have a promise that it's quick, and to keep us honest, I will start a stopwatch. Alright. Update for non-validated HTTP headers enumeration 35126. Mr. Tobe.
So the main thing here is we previously approved this API, and it was basically about enumeration. So the relevant types implemented IEnumerable. Just scroll down a tad just to bring it fully into view, Jeremy. Yeah. So for HTTP headers non-validated implemented IEnumerable, my request is that we not only make them enumerable, but basically allow you to look things, for HTTP headers not valid, be able to look things up. So implement iRead-only dictionary instead of just IEnumerable. This is really just a wrapper on top of something that is already a dictionary, effectively. So it's just implementing the interface, delegating to the relevant stuff under the covers, and then exposing the most valuable members of the interface, and in a couple cases with a slightly different name. So adding a count, so you know how many things are in it, exposing contains, because that's useful, exposing the dictionary's try get value, but exposing it with a different name, try get values, since that's the same name that's used on HTTP headers, and you're getting potentially multiple values out, and then also the indexer with typical indexer semantics. And then for the values that you get out, instead of IEnumerable, implementing iRead-only collection, which is just IEnumerable plus a count. So I've added a public count, I also overwrote toString. It's largely an implementation detail, but I figured I'd call it out. And I removed the two constructors. In particular, the implementation doesn't actually need to work with IEnumerable of string, and adding a constructor that takes an IEnumerable of string just adds more complexity to the implementation unnecessarily. And as long as I was getting rid of that, I also got rid of the other one. So this is what I would like to, the tweaks that I would like to make.
I assume there's some other constructor other than the default constructor.
There isn't. What I currently have defined is it's only for use with the HTTP headers stuff. So the only way to get one is from one of the above APIs.
So there's a non-public constructor.
Yeah.
Okay.
And then there's also default works, but it basically produces an empty header string values.
And then HTTP headers non-validated.count is the count of keys.
Correct.
Yeah. All right. I think I've asked all the questions that anybody's going to bother asking. Any objections?
Are we okay?
Really reasonable. I mean,
are we okay that the bottom one isn't new? You can't new it up at all.
I mean,
it kind of has such a general name, right? Like header string values.
I mean, if we wanted to add constructors, we would add a string constructor and a string array constructor, since those are the two things it works with today. My hesitancy is those are the two things that it works with today based on its current implementation, but there'd be nothing, like we could change the implementation to target the header store item info object that is actually what's stored inside HTTP headers, at which point accepting a string or a string array would just, again, be this extra stuff that it would have to manage. If we really think it's important that someone can construct one of these from a string or a string array, like we can do that. Or from an IEnumerable string for that matter. It just seemed like we'd be doing it for completeness, but no one would ever use them.
Yeah, so I mean, the reason why I asked on the GitHub issue was because people, when they write test code, they probably want to at least have some methods that take this header string values thing. But I take your point as in, like, we add these structs in order to make I mean, you can already do some of the stuff already. It's just that this is a more efficient version of that. And it seems a bit backwards if we basically prevent ourselves from making that as efficient as possible by adding conveniences that are arguably not that important, because realistically this type doesn't give you any expressiveness that you don't already have, right? I mean, you can trivially use a key value pair, you can use a tuple, you know, string comma string array. Like, it's not that this type does something that you can't do. It would just be a tiny tad more convenient for some people, but I also really don't foresee this becoming this major exchange type, right? It's just a freaking struct that holds two things, right? So we already have plenty of ways of doing that.
Yeah, and presumably from the HTTP headers class, which is public, and it's in fact public abstract, presumably if you're doing test, it's just this is the test route. You have to go make one of these guys and fill it with data,
yeah,
and now you can get these two off of
Scroll down, Jeremy. So like you can create, you could write this little helper function.
Yeah, so it's just, this is a wrapper on top of a thing that you can build yourself. You don't need to get
it's not super efficient
into the cursor
from a test perspective.
Yeah.
So I will bend to the will of the group. My preference would be not to add the constructors unless we've actually got people asking for them in a meaningful way. But if folks really feel strongly about it, we can add them. And it just means if we were to change the implementation in the future such that we didn't care to work with string or string array or whatever, we would just be carrying that baggage around.
I see it's written in the issue, but I missed the conversation, assuming it happened. Why not Microsoft primitive string values?
And have system.htp depend on it?
Yeah, move it. Yeah, is that the problem?
That has historically been kind of a problematic type, in honesty.
And the layer is wrong.
Yeah.
Like, we can't change the name. Like we talked about it when we moved extensions into runtime. We decided not to change the name, so it'd be really weird to put Microsoft.extensions in the shared frame.
And have HTTP depend on it.
Right.
Because it's not an extension at that point. It's obviously core.
I mean, we could. I mean, if we really felt like the type is super key, I mean, we could just type forward down this one type. But I agree that it seems odd to do that. And same argument as with the constructor, right? I mean, this thing is not this major exchange type, I hope, right? Because it fundamentally is just, you know, effectively a key and a comma separated list, right?
Yeah, but by the way, speaking of keys, I assume that you're going to use a consistent comparer between the enumerator and the try get values method, like either case sensitive or case insensitive.
Yeah, it's all case insensitive.
Okay.
Emo, I'm not sure I agree that this is an exchange type. Like, if it's used at all, like string values in ASP.NET, like it will be used in like interfaces. I mean, like in ASP.NET, string values is like in our header dictionary and so forth. Like, yeah, you need it to implement abstractions. Like you were already talking about it for testing and stuff.
The thing that
So to
I'm
be clear, I'm
not
not
keen
saying
on.
it's not. I'm just saying it's not a major type like iDictionary, right? I mean, like, yeah, I mean, any type is exchanged by someone, right? It's just all degrees of like how, you know, how much of the ecosystem benefit would there be if we were to make that the type rather than introducing a new one. But it does have the additional complexity of us having to type forward something down. And then you have the somewhat ugly API where you have like basically two different namespaces that don't seem to really, you know, mean much with each other, right? So that's kind of, I mean, yeah, it's a, you know, how much do we care kind of situation.
Yeah, it definitely feels like it should be the same type. Like to be able to swap things between like, you know, HP client headers and ASP.NET headers and stuff seems like it'd be actually something where you would want to share a type potentially. Be convenient for proxies and stuff.
Right, the ASP.NET type is a
Like
struct
if
too, right?
string values already existed elsewhere in somewhere a system that HP could reference, like this wouldn't be a conversation. We would just use it.
Right.
Yeah, to be honest, any type that we have in the BCL that is string values or string segment, both from the extensions library, we would probably have different behavior than those two types already have, because those types were meant specifically for the DI and extension scenarios and don't necessarily follow the same behaviors that we would want inside the BCL.
I get it's hard. Like, and I'm trying to think about how like ASP.NET could convert to this, and that doesn't seem easy either, right? But
well,
like,
I mean, that's my question. Like, it's a struct, right? Couldn't we just have a conversion operator that basically converts one to the other, and then you can basically pass them around freely with close to zero cost?
Not without a constructor.
Fair enough. If that constructor gets a bit more interesting, yeah.
But that's basically a different proposal.
Right. Yeah. For this, I'm totally fine with taking out the constructors and adding them later when we decide that we need them.
Yep.
But even then, you could get away with a one-way conversion, right? Potentially, right? If your goal is to get the systemlet HTTP headers into the ASP.NET one, then you don't need a constructor here. It's only when you want it the other way around, right? So we could still, depending on what the scenario is, maybe you get away with a one-way street, right?
I think for headers, you want it both ways for sure.
All right, and we have exceeded our time box. I think that we were approved of Steve's amendments, and the rest of the stuff can go offline or to a different issue.
Yep, sounds good to me.
All right.
If just to add to that, if someone wants to come up with a proposal for how we would move string values down, we should entertain that, and we can always revisit this as a result of that if it happens in 6.
Yes.
Stefan, do you want to take point on that?
I hesitate to commit, especially if we're trying to do it for 6. But yeah, I'll do that since no one else probably is that interested. I'll at least bring it up with the wider team and see, you know, how important we think it is on the ASP.NET side to try to consolidate, and we can get something started.
Yeah, I think it would be good at least to file the issue, right? If we can figure out funding who does the work, yeah, independent of that.
Right. Yep.
Okay, so our stated topic or theme or whatever you want to call it for today was code analyzers, or review the code analyzer proposals. So that's what we'll do now. queue a few of them up. Make the screen a little easier to read. All right. Do not do math with local date time 33764 emo.
Sorry, I almost muted. I filed them all, but I didn't write most of them. I think most of them were written by Steven, actually.
Okay.
Can you
I just
scroll
converted
below?
it.
There are a few examples to help clarify the suggested analyzer. So whenever there are operations that involve date times where the type or the kind is clearly known, we have to flag them. So, for example, if we're not supposed to mix local with UTC, and I believe there is no fixer. Yeah, no fixer applicable. It has to be manually addressed by the user.
So I guess I'm confused by the examples because by the title of this, I thought it was about concerns with like I've got a local time zone and I add an hour and I run afoul of what's it called? Happens twice a year.
Daylight saving?
Thank you. That's it. Daylight savings or something. But these examples seem to all be around. I have a date. I have one time that's UTC and one time that's local, and any kind of comparison, it gets flagged. Is that? I'm not trouble following this.
Yeah, that's how we limited the examples. Are you talking about the analyzer that you linked in a comment above?
No, I'm talking about the title. Do not do math with local date time.
Oh.
I don't see math here. I see comparisons.
All right. And maybe we can continue addressing, investigating this one a bit more. Yeah, I say we skip this one. We continue with the others just to clarify, to make sure we clarify what math means, as the title stated.
I mean, you have in your example, you have one where you actually do subtractions, right? So I think the spirit of this is basically the idea that you shouldn't mix local time with UTC time, right? And so it's kind of basically, if we know the kind, then any sort of comparison or math between them is basically bad, right?
I guess, but like to Steve's thing of you have a local date time and you add an hour and daylight saving kicks in, like I think that date time handles that and can be what you want, and so I think that if that's the thing we're flagging, that feels like it would be too noisy. So I think that whatever the examples are and the title should match so we understand what we're talking about.
Don't you also still have the same issue in that scenario with UTC, because UTC has daylight savings as well, and so they'll go from
No, it doesn't.
UK has daylight savings time.
The UK and UTC are different.
That's not UTC.
They're BMT.
Okay.
British Mean Time is UTC with daylight saving.
Okay.
UTC is the never-changing time zone.
Okay.
That's why it's the universal one.
This is why I don't do date time.
Yeah. UTC is the good one. Everything else is stupid.
I mean, I've been...
Including Pacific Daylight Time.
I think I agree with the principle of the rule. I'm very skeptical that the analyzer can handle that, though.
I think also without like more complex flow analysis APIs from Roslyn, there'll be a lot of our own flow analysis that is going to be problematic.
Well, even ignoring flow, right? Most of the time you don't do specify kind, right? You have a method that takes 2 date times. So how the heck would we know where they came from? So it's I don't know that like in practice I don't think we'll actually catch the bugs, because unless you can inspect the object, like I don't think you can do anything meaningful. If that makes sense. I mean, I think this was one of those examples where maybe thinking of logging or something where we actually tell you at runtime, hey, we just noticed you did a operation involving 2 date times with mismatches would be more useful than trying to do an analyzer, because I don't think you actually statically know enough most of the time to actually help you. I mean, sure, there's examples where you can, where the datetime.utc now dot and then something. Sure, yeah, of course, you know that this is UTC at this point, but I'm not sure that that's the majority of cases. Would be my guess. But yeah, it seems like we should punt this for now, right?
I just went for skipping over it, and I'm hoping that it'll just get marked as no longer ready for review until it gets a more clear purpose. But I can, do more. I guess, actually, exactly what we did is I should mark it as needs work.
Yeah, exactly. Just leave the notes of like clarify the thing, and then I think what I'm missing here is also the. Do we actually believe that we can catch all enough interesting cases of static analysis? But maybe that's not the bar we have. Maybe the bar is we don't have false positives. We just have a ton of false negatives, but it's still better than nothing. Sounds good. Thank you.
Do not pass UTF-8 JSON reader by value 33772.
Oh yeah.
Hooray!
Is this specific to UTF-8 JSON reader, or is it more like any ref struct?
Um,
I guess not any ref struct. You could pass span by value.
It's any mutable struct.
We had an idea that we were batting around earlier regarding move only types, but that would be like kind of a wider language feature. If we had that feature, I think we wouldn't need this particular rule, because we would just mark UTF-8 JSON reader as a move only type. Same thing that we would do for like value string builder and so on.
I mean, that one's a little different. It depends on how we would do move only. If it became like a C# language feature, we wouldn't want it to be one. If it became an analyzer thing, then we would, because there are times that it's very useful to intentionally clone the reader by copying it into a new local.
Yes.
And
there would be syntaxes for that, though.
Right. So but yes, the general idea is if you've passed a reader into a method by value, you probably have a bug.
This, I think, is a very appropriate stopgap until we have a wider language feature.
Should it, instead of being specific to UTF JSON reader, should the rule be configurable with a list of types that shouldn't be passed by value? I don't know. It feels. I mean, we can do this if we want to. It just feels very specific.
I mean, I agree with that. I mean, the question is, like, do we know of any other types where we effectively have mutable structs where bad things happen? I mean, we generally avoid them, right, by construction.
Value string builder. If we had this in value string builder, we would absolutely just make it public, right?
Well, but that's the thing. We don't have it.
Jeremy's shaking his head.
I will fight that until we have move only structs.
Pretty much any mutable struct, and we have a bunch of those.
Like I think system.hashcode is one, but we don't expect anyone to ever pass that anywhere.
Every strongly typed struct enumerator.
Yeah, but people don't pass enumerators.
Yeah, I mean, I don't know. Tuples are mutable too, but like, there's really nothing bad usually that happens with tuples, right? Either.
Right, but like for example, if you did pass an enumerator, you would absolutely want to do it by ref. Now, to your point, Jeremy, like it's certainly not as common as other things.
Right.
But if you were passing one around, it would have to be by ref.
Yeah, because the reader this came out of when people first started using it, they were making this mistake because, why would there be a mutable struct? And then we were seeing all sorts of complaints of it's, cycling and other things like that. It's like, well, I'm in an infinite loop now. It's like, well, yeah, because see this step right here? You had an implicit rewind. Right. You wrote the infinite loop, not the reader.
Let me ask my question a different way then. We shipped this rule, CA 1234, do not pass UTF JSON reader by value. And then we get a request, I want the same rule for spinlock. Do not pass spinlock.
Yeah, sorry, I agree with your point that we should that this should be do not pass mutable value types by value. Okay. And then that somewhere there needs to be a list. Like I think that's totally cool. And I think that the fixer would be the same on all of them, which is the call site should change to by ref.
I wonder how noisy it would be to flag ref structs passed by value rather than read only or ref read only structs.
Well, but the refness of UTF-8 reader isn't really its problem. Like the refness isn't why passing it by value is wrong. It's the mutability. Yeah. It's you pass it to a method, you call read, and now you pop back out to the caller method. The caller's version of the reader hasn't moved.
Yeah. I mean, I think the problem is you can't quite generalize it automatically because we have, like tuple, for example, you really don't want to flag all copies of tuples, right? That would be pretty bad. So I think the one thing we could do is we could either invent an attribute that you put on a type and the thing is keyed off of that attribute. But I'm also okay with saying there's a hard-coded list in Analyzer for now. And then, once we exceed 3 or 4 types, then we come up with an attribute and put the attribute on the type and keyed off of that.
I'm very skeptical about doing an attribute without Jared first coming in and saying, this is okay, will not block future language features, and etc.
Why would it block a language feature? I mean, this is literally just an analyzer that tells you something that you're holding wrong today. The API is already shipped, and nothing prevents you from making that bug, right? We just tell people don't hold it like that.
The issue ends up being that I think the issue ends up being whether or not it's a breaking change to go from the analyzer to the language feature, because the language feature will likely start reporting as an error that is non-disableable rather than as a warning.
But that's irrelevant because the type's already shipped. So so the question is, could we make UTF-8 JSON reader later on use the language feature, right? But that's a completely orthogonal thing whether we ship an analyzer now that tells you that you're doing it wrong because the type is already shipped. So like the damage has already been done. It's just that users can't know that, right? So I think our analyzer, whether we ship one or not, does not increase that footprint. It's just that people just don't know that they have that bug, right? So that to me, why I think holding it hostage by language feature seems wrong here because it's like kind of like this discussion, like should we use a language feature would be more interesting when we design mutable structs, right? And that's why we haven't shipped, for example, mutable string builder yet, or sorry, value string builder, right? But I think that's our general problem in the BCL, that when the language feature comes online, very often we can't make the BCL types use the language feature, right? So we can't make key value pair, for example, a record, right? For the same reasons, right? But that to me is an orthogonal problem. That's just the BCL types ship first, language feature comes after, and then we can only use the language feature for net new types. But for the types that ship, it seems reasonable to have an analyzer that tells you when you're doing it wrong.
Yeah, and with JSON in particular being, a net standard targeted semi-oob, like putting an attribute on the type wouldn't necessarily help because if your package closure has an older version, it wouldn't have the attribute on it.
Right.
So, yeah, so I think it's that we can start in with, a hard-coded default, and then I think that config has a way that you can merge things in, and that we want anything that we think is problematic, or I don't know if we can teach it to get things heuristically. So the struct-based enumerators are probably all end in the word enumerator, our value types, and our nested types, and that like it can just say, you know what, if I see this pattern, like you shouldn't have passed this by value.
Yeah, that's probably fine.
In particular, this cannot flag vector 2, 3, or 4, which are mutable structs, because they are expected to be passed by value for performance reasons.
Yeah, that's why I said, like, I think keying it off of the read on the lack of read-onlyness of a struct seems wrong, because there's just too many of them, and many of them it's just fine to pass them by value, right?
Yep.
I think that's why I said I think the one thing I agree with Tanner is that we should not invent an analyzer to basically build something like value string builder. That does seem wrong. That's something that we should talk to the language first and say, hey, we would like to do these things. What would language feature for this look like, so that we don't do this hack with an analyzer, right? Because the thing that Jared has said many times is that we can't reliably detect when copies are being made. And so just passing into a method is just one of those examples where a copy would happen. But there are many other cases, like, you know, you invoke a method on a property or something, and then the compiler introduces a copy, right? So it gets very tricky to do this analysis correctly, right? And that one I would agree with. So I would say, let's not invent a way to make mutable value types safe, right? But this is more around like, okay, we already have a mutable value type. People fuck it up all the time, because with readers it makes sense to have methods, right? Where you have a method read person or read something, and you want to take a reader, right? And that seems common enough that it seems okay to flag that and tell people don't do that, because it's really confusing when your reader doesn't advance.
Would this also then flag you pass UTF-8 JSON reader by in, and then you try to call a method that mutates on it, because that also creates a copy, which is also problematic. It's still being passed by reference, but it's not going to mutate the state like you expect.
Yeah, but at least on that one, anytime you call read on it, like, you haven't changed the one in your method, and like the next time you call read, you get the same thing. Like, wait a minute. The problem is when you do complex work through a call chain and then pop back up, and now you don't understand where the rewind happened, because you don't see a thing that didn't get modified.
Okay.
But I mean, I agree. Like, in kind of shipped before it was ready, I think. That really it should have been a compile error to call a non-read only thing on a thing passed by in, but you know.
Should also never have had implicit semantics.
Here.
Yeah,
The chair would like to commend Tanner for that comment.
Yeah, I think this is the other reason why I think scoping that rule to something that we kind of hard code right now seems reasonable, because it won't catch everything, right? It will only catch like the very obvious bugs, right? But that seems okay.
And so are we going to say from the start UTF-8 JSON reader and what's the other one? Spin lock or whatever?
Well, the way I would do it is what Jeremy just suggested. I would probably hard code all the enumerators by just saying it's a nested thing, it's a struct, it has enumerator in the name. I mean, it's going to be mutable, we know that, and passing that by value is bad, we know that too. And then the error message should basically say something like, do not pass quote type name quote by value, because it's mutations aren't observed or something to that extent, right?
Yeah.
And
Do not pass mutable type thingy by value.
Yeah.
Right, but I was asking specifically included in the list of things that we're saying today should be covered. We're saying UTF-8 JSON reader, the enumerators under the qualifications, and
yep.
I was thinking spin locker, whichever one it is as well, since that's the other common one.
Yep. Yeah, that's why I asked earlier. Like, if you have a list of things that we know people, often make mistakes with, we should add that to the list. If the list is long enough, I mean, maybe making an attribute now is also reasonable. If it's like less than 5, I don't think it's worth it.
Right. But again, the attribute has the problem of, if they're targeting net standard, there are no attributes.
That's true. That's true.
For like spin lock, assuming that's in net standard, that version of spin lock wouldn't have had the attribute on it, so we'd still have to either say we only care if you're targeting net in or higher, or we have to say that there's a list in addition to an attribute.
Yeah, I mean, probably I would do the latter, but I think the problem with a hard-coded list is it's just a pain in the ass to maintain, right? But yeah, it's fair.
All right, so I think that there's some interesting room for what are we actually reporting? I think probably the best thing would be the parameter declaration.
Yeah, I mean, this is the thing, right? I feel like if we try to find all copies, it's going to be losing proposition.
Yeah.
Because there's just too many cases. I think, and then in case of the reader, really the pattern that people do is they take their code extract method, right, and then they get a method out where the reader is a regular argument, right? So if you just flag parameters of these types that are non-ref, which would include in, we just flag those and say regular or in, don't do that, you should pass it by ref.
So we'd only flag the parameter. We would not try to see the common case of I'm consuming someone else's library and they've authored it incorrectly, not to take it by ref.
I mean, if they took if they took it by value, there's nothing you can do to it.
Right. There's nothing actionable there other than saying, like, hey, you're probably going to have a bug here, and maybe you should go tell the library maintainer. But
yeah, I would select the
seemingly
declaration.
better.
I mean, generally speaking, no, right? Because ignore for a second the library scenario. Just say it's all your own code. You have 20 call sites in one declaration. I'd rather see the one diagnostic on my declaration than my 20 diagnostics for when I call it.
Right. I definitely agree on that when it's all your own code. But I'm thinking of the case like, let's say that Newtonsoft JSON shipped and they accidentally forgot to put ref on one location. And you're calling that method as a library implementer, and you have no clue that the bug's going to be there. And you're going to be dependent on Newtonsoft A, recompiling with the analyzer on, and B, actually picking that new thing up, and C, knowing that that bug was there in the first place.
I mean,
so,
I hear what you're saying, but you can make that argument literally for every single rule, right? And we generally don't analyze your dependencies. We generally analyze your code, right? I think the problem is if you take your idea to the extreme, I think the problem is you drown the user in unactionable things. I think that's generally not better, because realistically the idea is that the guy that wrote JSON.NET also at some point updates his tools, right? And then he gets the diagnostic. I think the problem is if you try to find every possible bug in user code that might be there.
Yeah.
It's the trade-off between signal to noise, right?
Yeah, so for the fixer can easily see that there was the parameter that wasn't passed by ref and change it to pass by ref, but it can't now find all the usages because those lines of code would have themselves had to have already had a diagnostic painted on them, right?
Well, it's basically different passes, right? You can either have an analyzer that walks over the symbols that the user defined, or you basically have an analyzer that walks over the operations, right? And so then, it's just a different kind of pass you're doing. And then how the diagnostic gets there is not important, right? The fixer then refers to the diagnostic, and then the fixer gets invoked for whatever the diagnostic you put in there. So, I mean, that would work either way, right? But
all right, I love hand wavy bullets. All right, so that's.
I mean, the question is parameter the only case we care about? Anything else that is common?
I mean, like, you could maybe get a return, but that one feels easier to figure out and understand. Because, like, hey, I returned this reader and then I used it and, like, it didn't change my state. Oh, because it's torn state. So I think the one that creates the subtle problems is, as you said, the extract method, and you end up passing a thing in by value, and it's like, well, I'm sorry, but that doesn't do what you think it does.
I mean, I'm wondering honestly whether if you declare a public property, or it doesn't even have to be public, if you declare a property of those types, it's probably wrong too, right? Because clearly you get a copy every single time you ask for the value, right?
Okay, I mean that would be a diagnostic
generally,
with no fixer because we
don't
can't
do
know what
that.
you want to fix.
Basically, make it a field, basically, right? You can't have a property. I mean, that would be the fix. Don't make it a property, make it a field.
Well, I mean, the other fix is return it by ref, but that's only applicable if it's a field of a class. But
Can you
that
have properties returning ref? I guess you can.
yeah,
Right?
yeah, you can have ref and ref read only returning properties. You just can't return, stack value refs, and you can't return fields of structs from the
that seems
struct
reasonable.
itself.
I mean, that would probably handle now pretty much most of the problems, right? If we
Right,
say,
because most people just write classes. So
yeah.
Okay, so you want it to also look for return types because that'll catch the property.
yeah.
Well, sort of, but yeah. Yeah, basically output positions, right? And whether it's a method return, a property, or yeah. It's probably less common, but I can totally imagine somebody having a thing called XXX reader that has a UTF-JSON reader as a property on it. People like to do shit like that.
All right. Okay. Anyone want to give a grunt of assent to my notes?
I have a question. What does it mean to also support loading other types from config? You mean from a config file?
Analyzers have the ability to load additional configuration for things like the .editor config file. So you can specify details about the rule and have it load data from there. Like existing rules allow you to control whether it applies only to public methods or to public and internal. And if you look in the editor config, it'll be like .NET.ca1345.visibility equals public comma internal comma whatever, and the rule can load from there. So this is about doing the same.
Yeah, and I feel that there are some existing rules that have load lists of types from config. I don't know what any are off the top of my head, but it doesn't feel like a thing we're inventing here.
I'm pretty sure I've seen it in the Rosen Analyzer repo somewhere. It might have been in the Rosen specific ones though.
All right.
I mean, there's the whole like blocked API analyzer that's general, and it's entirely about giving it a list of things.
Yep, that's the one I'm thinking of. Thank you.
All right. So, are we good with this one?
Seems good to me. I mean, Carlos should say because he's the one working on it. Carlos is nodding, so.
I think it looks good enough.
I have a question on the fixer, and if it's flag only the parameters, then I'm not sure. The updating all calls might be difficult.
Yep.
I mean,
the idea, I think, is to
I
double
think
click the
that
compiler error.
Just fixing the parameter might be better.
I mean, the problem is you may not be able to fix the call side, right? Because just applying ref to the argument may not work if it's an expression, for example, right?
There we go. Hand waved,
Okay.
if able.
I mean, I don't know what the Rosen bar is, but my understanding is you can totally have fixers that gets you halfway there, and then the other half you have to do manually. I mean, that's how rename works, right? You can totally rename stuff into something that has conflicts, and then you just get compiler errors, and you have to deal with that, right? That would be the same here. The fixer would just make it ref, and then all calls have stop compiling because you have to pass the argument by ref. I think it's reasonable.
That's fair. Like you mentioned, catch it in multiple passes, and so maybe there's already enough infrastructure there that it can be done. Of the first pass puts diagnostics on the methods, and then the second pass looks for calls to any method that it's already put the diagnostic on, and puts a diagnostic on those to then make the analyzer understand what to fix. But outside the fixer understand what to fix. But if it's not possible, then sure,
Well, the
the
problem
fixer
is it
that
depends
says,
on the call side,
well,
right?
this is now ref, and now you get to deal with that.
I mean, imagine what the call set is, right? If the call set is an expression like 1 plus b, for example, right? Then
Sure.
you have to extract it into a local, which you may not be easily be able to do because the whole thing is an expression or something. So like the rewrite might be fairly non-trivial on the call side.
Right.
So that's why I said like I'm okay with saying, yeah, exercise left to the reader, right? You just like, I mean, I think to me the bigger problem with a fixer is if the fixer changes half of it, the code compiles, but the other half isn't done. That seems pretty bad because then you just find out at runtime that stuff doesn't work. But this one is, yeah, it does half of it, but the other half, no, definitely doesn't compile. And so the user has to walk it before anything happens. So you basically get at least a to-do list from the compiler, right? And so that to me is generally acceptable. What's really bad is if stuff compiles and then it just doesn't work at runtime.
Okay.
Because then you have no idea what to do. You're just broken now.
All right. I've added a lot of weasel words.
Yeah.
Warning, right? Severity warning.
I think that's generally what we do, right? I think we generally don't do arrows.
Oh yeah.
I think the only one where we have an arrow right now is the preview one. Everything else is kind of, you're probably holding it wrong.
All right. The category previously was marked as reliability. Do we still believe in that?
Yeah. I mean, I don't know what else it would be.
Correctness.
Yeah, there's like correctness or usage or ham sandwich or something.
I don't think correctness exists, does it? I think usage does, but usage is also weird. That seems more like API usability. I mean, it kind of is, but not really. Because you're authoring APIs that there's no way where they can work. I guess that's more correctness than it is used.
All right. Prefer static read-only span of byte properties over static read-only byte array fields. 33780. I'm guessing Tobe?
Yeah, so this is basically all those places where we have private static read-only byte arrays that are, consumed only for things that accept spans, and so we go and replace it with private static read-only span of byte property that returns the new byte and rely on the Roslyn compiler's transform that puts the data in the static portion of the array and just returns the pointer to it. Ideally, we'd be able to do this for any type, but right now the compiler only does the relevant support for single byte types, so single byte primitives, so byte, bool, and sbyte. There's an issue open in the repo, in the runtime repo, to add an API that would then in turn allow the compiler to do it for everything. So if we add a rule here, we'd want to make it general enough such that in time we could update it to support all types and not just the ones that are currently supported, but start with just the ones that are currently supported. So basically the rule would say if you have a private static read-only byte array equals new byte array and it's all constants and it's only ever passed basically to something that can take a span, a read-only span of byte, or read-only span of whatever the type is, then we could transform the field to be a property and avoid that array entirely. It's pretty complicated and it's advanced, so it's sort of a lower priority thing, but you see us, especially in .NET runtime, manually finding these things every once in a while, and then a PR shows up to change it.
So the actual support for directly returning a read-only span is for single bytes only, but there is the support for efficiently creating an array, such as a static read-only uint array, via all constant or partial constants, would this also flag that case? Like if you're locally doing locally declaring those the other primitive types as well?
Sorry, I didn't understand what you were suggesting it would flag. Because if you already have a private static read-only uint array equals new uint, like that's already doing the right thing. So what is it you were suggesting you'd be looking for?
Do we also already, does the compiler also already do that for inline declarations of arrays?
Oh, you mean
And-
if I store that into like my local array equals new whatever?
Right. I think the compiler handles it, but if not, then should we also flag that with this analyzer?
I see. I have no idea what the compiler does in that case, though it's easy enough to check. I mean, presumably in that case, whether or not it's storing the data in what portion of the assembly, it's still allocating a new array every time. So, you know, for other reasons, you'd want to move it into a field. If you
it doesn't allocate a new one every time.
would have to.
Well, yeah, if it's in a field, it does, but not for static read only.
No, not for static read only. But if
Okay,
you're
yeah.
I thought you were talking about a local.
Yeah. Sorry, I've got a couple. I was hearing two things at once and not connecting the dots.
Okay.
My brain's not working.
I was like, if you have uint bracket local equal new uint or new open curly and then a bunch of things, close curly semicolon. I mean, maybe I was like, does the compiler do this array never got passed to anybody, so it doesn't matter that it had an instance? Like, I don't think so.
No, it definitely does not.
I don't think it can promote that to just a read-only span pointing at the stack or at the code space or wherever, but yeah.
There's also the inverse of this, which I don't think we've mentioned a rule for, but it would be nice. Until we get that additional support in the runtime and the compiler for doing any type, you know, once a month we'll get a PR that someone does the new pattern. They'll do like private static read-only span of char, myprop, arrow, new char, whatever, thinking that the compiler is doing the right thing, and it's not. And so they're actually significantly de-optimizing their code by doing that. It'd be nice if we could flag that as well. Hopefully that rule dies in time when it actually is doing the right thing, but right now it definitely would not be.
I mean, I don't want to really derail things, but when do we expect it would be able to? Because you'll have a little Indian versus big Indian problem.
Right.
Well, go ahead, Jenner.
I was going to say the proposal. So the way the other types work today is there's a method in runtime helpers called initialize array, and so if you're declaring a static read only byte array, for example, then the runtime initializes that as new byte of appropriate size, and then initialize array, the created array, and then a runtime field handle to the static read-only data that's been embedded into your PE file. And that's effectively how, for the read-only span version, it does the same thing, except instead of creating an array and then copying the data, it just bit blitz the pointer to the read-only data into the span as the ref field. The proposal is for a runtime helpers initialize read-only span equivalent, which will do the endianness fix up one time, and then just blit the pointer into the span. David Wrighton had a prototype, but then there wasn't enough push from the language or libraries to finish that, and so I think it's just waiting for another push from us to say, hey, we'd really like this. It's going to be very good for perf work. So can we just, finish that prototype, get it checked in, and then get the language team to correspondingly make the few tweaks to unblock the other types?
Okay, so basically it would, just thinking
Short
out loud,
answer
it
is
would
give
pass
the runtime a hook to do the efficient thing in the 99.999% case of little endian, and do the more expensive thing when it has to for big.
Yeah, I was gonna say basically it would get the data pointer or code pointer. I don't know what these things actually look like in in libraries. But it would get the pointer to the static data, and it would say, "Hey, it's a Little Indian PE file, and I'm Little Indian. Return the pointer."
Yeah.
And otherwise, it would be like, "Fine, go make a copy."
Yeah.
Yeah.
Okay. Fair enough. So that doesn't seem too intractable, but we would need to understand like target pack and support, and it does seem complicated.
We wouldn't have a lot of complication there. We'd just look for the same runtime feature flag that the compiler would end up looking for. So if you're targeting a library where runtime features dot, blittable constants exists, or whatever we're going to call it, then you light up the analyzer for the other types.
Okay. And then speaking of that, does this pattern work on net standard, Steve? Tanner?
Yeah, it's a compiler thing, so it really doesn't care. It works on net framework and
Okay. It could have been depending on like FastSpan or some other thing we had in core. So
no, it's just a pointer, and the pointer's pinned, so it works anywhere span exists.
Okay. So then the question I have about feasibility on this is, this basically requires finding all literal declared static fields, or I guess read-only fields, because it could be read-only instance as well, I think. Maybe the pattern doesn't work for that. But find all literally declared arrays, and then now find all the usages to make sure that they would be compatible with span. Can we do that kind of multi-phase approach with one analyzer?
I think it's just look for any expression which creates an array, and when you find one, check are all literals constant, and if yes, flag it as this should be a static read-only property, and if no, then there's the potential for us to say this should be a static read-only field.
well, the problem is you might be passing it to something that only works with a byte array. So the moment you change it to be a read-only span of byte, you break the call site that was using it.
Yeah, but if it's info level rather than warning level, then the user has the ability to decide, is this one appropriate or not?
I think that's going to be pretty noisy. There are lots of places where these things are used, like they're passed to async methods that they can't be span.
Right, but they can be static read-onlys in those cases, which is still better.
I think you're talking about a different potential rule, which is I've got some array that I'm allocating locally or in an instance field, but it's always constant, and I find that I'm never mutating it, so then I want to promote it to a static read-only. Is that right?
Yeah, I guess that's the case. Yeah, the mutation's probably likely the problematic part there.
Yeah, because the version here is you've already decided it's a static read-only field.
I mean, to be clear, I'm fine with that too if we want to do the analysis for that as well. That's just, I think, a separate thing.
Yeah, okay, that's fair. My brain's just not working at 100% today.
I imagine you're still back on the datetime thing and thinking about how your life's going to change when datetimes have to work with hardware intrinsics, and then you're actually going to have to care.
Yeah.
All right, so
I'm going to have a new nightmare tonight. Thanks, Steven.
I think we should add SIMD now, and SIMD UTC now.
All right, so presumably we want the analyzer to only look at static read-only array field decals that use a literal initializer? Like, is that the scope that we want for the start?
Say one more time, Jerry.
So basically, pass one, find all static read-only field declarations that are an array that is initialized with new curly, or just curly, because fields can do that.
New curly filled only with constants and of a supported type.
Yeah, well, and then the note that for now it also has to filter it down to these three types, and then it needs to do a candidate elimination pass to to see if they were always coerced into span in their usage.
Yeah.
Uh,
And I think, and that's the part where it becomes, like, the first part is trivial. The second part is where it becomes complicated and more concerning, is potentially expensive. And so we'd have to weigh the benefits versus the cost to the compilation.
all right.
The visibility, do you want to mention it, since the examples were explicitly flagging private and internal?
And I guess only non-public things, right? Because public things, you're if it's protected, or I mean, technically protected would work if the type is internal. I guess internal also would be valid. Sure. So as long as the type can't be seen outside the or the field can't be seen outside the assembly. And we'll pretend internals visible to does not exist. All right, seems legit. And then the fixer's easy. It only has to change the field declaration. I guess it should also change the casing, which means it now needs to update everything. Yeah, I'll leave it as just be fixed. Okay. Anything else? Anyone want to disagree with the visibility filter? This thing on?
I think it should be any visibility, not just private, protected, internal. If you've got a field that's a static read only, and it's any visibility, you likely want this optimization.
If it's static, if it's protected static read only, you don't know what your callers are doing. You can't change it. That's an API breaking change.
Right.
So that's why it's the if it can't be seen outside the assembly. You can be a public static read only on an internal type, and then you're internal, and that one can be changed.
But you don't know whether the API shipped, right? I mean, for all you know, the person just typed the code 10 seconds ago, right?
Maybe there's a different diagnostic we can put on that, on public static read-only ones, and you can have it be something like, because the right fix in that case would be have public static read only x equals, and then the property, or I guess no, that wouldn't work because the property returns span.
I mean, I wouldn't even bother checking the visibility, to be honest. Like, the important thing is the pattern, right?
Okay, I mean, like,
is,
our general guidelines, even though we have naming rules for protected fields and stuff, our general suggestion is don't have visible fields.
Right, but like, I mean, you could imagine, I mean, very common patterns, people have an internal type with public members, right? So the effective visibility is internal, but
why it had
the declared one happens to be public, right?
Or the containing type is one of those visibilities.
Sure.
Yeah.
Like, it just seems to me like, I don't know, like I mean, we generally don't have visibility filters for anything that has to do with API shape, right? Because we don't know whether the API was shipped or not, right? Like, if the API was literally written 10 seconds ago, well, now is the time to fix your API because you haven't shipped it yet.
Yeah, well, that's why I was starting to take the note that Tanner had said of basically use a different diagnostic ID for externally visible and non-externally visible, because if it's non-externally visible, then you should just fix it. And if it's externally visible, then you should consider fixing it. But part of the consider is
sure, but like,
not if it's shipped.
But I think the diagnostic ID doesn't help you here because it's not a diagnostic. It's not like you suppress one or the other, right? It's you would have to suppress specific APIs because you don't know yet. I mean, we don't know which ones were shipped and which ones weren't shipped, right? So that's why I think like
fair.
having a different ID is probably not useful.
Yeah, I guess.
And also
it's also.
Also, we don't.
Go ahead, Dima.
We don't. Yeah, I mean, we don't do it generally, right? That's my other question of like, I mean, are we saying that basically any analyzer that flags an API shape now would have to differentiate between visible and non-visible APIs? That seems odd.
We do have that new analyzer that's supposed to compare against previous ref assemblies to determine if you've made breaking changes. And maybe it would be nice if we could rely on that data from that analyzer to determine whether or not to flag in this one, or if we could just say if the user makes the fix, then the other one complains. But both of those don't seem honestly like perfect options.
I mean, the problem is the other analyzer is probably not going to help you much because it's like, the sad thing is, like, this whole comparison with the previous one, you can't quite do as a Rosen analyzer because you need to do it after the multi-targeted build is finished. And then you have to compare horizontally across your builds, which within the Rosen analyzer, you basically only have access to the current compilation, which is only one of the 4 you're building, I'd say, right? And so that's why it's not really an analyzer. It's more like a build tool that runs after. And yes, we could persist data, and then that data could be fed back into the analyzer or something. I mean, but it would be very clunky. So we haven't done that yet.
Yeah, and since we generally discourage people from having visible fields, be they static or instance, it probably wouldn't have too much noise. So, yeah, just ignoring the visibility seems sound. And if we get a lot of pushback, then we can tweak it.
Is it on by default or would it be off by default?
Yeah, so I guess that's the last 2 pieces is default visibility, and I guess there's default visibility, default enabled, and category. So I agree, category performance.
I think that most. Go ahead, Emil.
Yeah, go ahead. Yeah, I was asking my impression was that the performance category is off by default, right? Or is there some that are on by default?
That was going to be my basic statement / question as well. My assumption is that most performance fixes, because they're not like reliability or correctness, are I want to opt into seeing like what can I do to make my perf better, because that can be like really, really noisy depending on what analysis we're doing.
Yeah, so I think it can be on info, or do we just say its default is none? / whatever the disabled behavior is.
Yeah, that's the other question that I actually don't remember the answer to. Like, I feel like based on my exploration yesterday, it seems info is very mundane right now. Like I have like 50 violations in the solution or something, which kind of tells me that I don't think everything is info by default. We must have some subsetting there as well.
In level IDE suggestion, I think that's the one that's above none and below info.
Yeah, I forgot what it's called, but like in BS, it's kind of there's like warnings, errors, and messages, right? And whatever shows up there, I think that's what I meant by info.
Fair, but like I think info is a level, and below info there's a thing that I think is called IDE suggestion, which is the like it where it puts the ... under something of like, I have something to tell you if you care to listen. But the command line compile would never report it at all. Info's similar. I think IDE suggestion, you can't ask what are all the things in the solution that has this. I could be wrong.
I see. So basically, it's like when you happen to stare at a particular line of code and you see the 3 dots, but you don't get drowned in them. Yeah, I think that's reasonable for this as well.
Yeah. I mean, do you have thoughts, Steve? Are you still with us?
Sorry, I stepped away for a second. What was the question?
The default level for this analyzer?
Oh, info.
Okay, so info, IDE suggestion, and off are the 3 candidates.
Yeah, I mean, I think it would either be... I don't think it would be off unless there was a perf issue or we had a bug in the analyzer that made it very noisy. But it shouldn't be noisy if we do our job right. At that point, it would only be off if it was just too inefficient for it to be on in general. And at that point, then I think it ends up being either info, or if we're concerned about it being too low level for the vast majority of folks, which is a valid concern, then we would make it hidden instead, which in the IDE basically means it doesn't show up in suggestions, but if your cursor is in the right place, it shows up as a ... and you can fix it for that line and you apply it to, all fixes for the whole solution.
Okay. So I think it sounds like we want info unless something suggests we need to move it to a lower level.
Yeah.
Right.
Makes sense.
Avoid unnecessary string concatenation 33783.
Gumak is ready for review.
It was me.
Okay.
I have a few examples below. Let me remember this one. Yeah, it's the idea is to offer optimizations to simplify whenever you have to concatenate strings. And we and I thought of as many cases as we could. The idea is to avoid generally 2 concatenations if you have conditions in the middle.
Does this take into account whether or not it's constant concatenation or non-constant concatenation? Like there's multiple places where I've seen code be like long string plus line break, another long string that doesn't want a literal line break in it. And it's just 2 constant strings, so the compiler will make it 1 constant string at compile time.
No, I
I
don't
think
think
that
I added cases with constant strings.
I think this is when you've had a string L value that was built from concatenation, and then the only thing you do with it afterwards is concatenate it with something else unconditionally. So that saving the intermediate was unnecessary.
Well, it's also the opposite, right? When you concatenate unconditionally before, and then you have a condition after, right? That's the example that is right now at the top of the screen. If you scroll up a little bit, right? It's you first do result S1 to Sn, and then you have a condition, and then depending on that, you concatenate something onto it.
I guess I would, if an analyzer suggested that I do this, I would turn it off.
Well,
And
that's a fair statement.
Well, like this is unmaintainable code. This is if it does it after you've written it, that's wonderful. If it does it to your code, you're now destroyed. Because now you need to update both sides if you change the precondition concat.
There's also times where you want to have it in local, so it's easier to debug or other things. And I would think that the fix here is not to inline the concatenations effectively, but rather to go use string builder so that you're not doing multiple string copies. Because this is going to do in string copies where in is the number of concatenations minus 1.
Well,
all the
not really, right? The compiler
all
will
the pluses
rewrite
get
this to
one call to string.concat. Yeah.
Yeah.
Does it?
Yeah. No matter how many pluses
the
you have,
compiler
it's one
already
call.
does that. I think the problem is that if you split them across lines, right? That's why the compiler can optimize the result 1 and the result 1 plus equals x, because now you wrote the code in such a way that you have multiple concat calls, right? But if you write it as one giant thing, then the compiler can basically emit one call to string.concat. But I kind of agree with Tanner. Is like, I don't know, like depending on the number of arguments, I think string.concat just does the string builder effectively, right? I think we have like overloads for 2 or 3 arguments that do something special, and then the params one just does the string builder, I think.
My recollection is it goes up to 5 special ones, and then it's params. But the param string doesn't use string builder because it doesn't need to allocate it. But it does the one output allocate and then all the copies into it.
Interesting. Okay, so it does actually something better than string builder would. Okay.
Concat object. I don't know. Does something. I don't see the word string builder in it. But
I do think string builder would be a great recommendation though for this sort of conditional code.
You think it would, or you think it would not?
It would be.
Yeah, I would agree with that.
It seems almost like there's 2 things. One is, maybe write everything in a single statement if you can, so that you get that string concat optimization. And then there's another one that says if that's not valid because there's some condition or something, use string builder.
Yeah, and I think that string builder would only be less efficient if you have less than 4 arguments, because with less than 4 you get the overloads, but with more than 4 you have to allocate the array for the params, and so you're allocating either way.
Well, but string builder is going to allocate a char array large enough to hold the entire result versus a string array with just one element per input string.
Yeah,
that's fair.
I mean, I don't know, like I think to Jeremy's earlier concern, it's like, are we creating better code or worse code, right? And that kind of depends on the length of the string. So that literally S1, S2 is not so bad, but if they are like, sizable literals, then yeah, you can totally create a mess that might be slightly more optimized, but now it's like completely unreadable, right?
I mean, if they're literals and they're all declared as const, then no matter what concat you end up with here, that's the compiler's job to fold. Once you end
Well,
up
the
with
problem in practice is that you often have like literals, but then interspersed with non-literals, and the compiler can't fold them, right? The compiler, in fact, is actually quite dumb. If you have I think if the literals are all on the right-hand side and the left-hand side starts, there are cases where the tree is structured in such a way that both arguments are literals, and the compiler doesn't do the looking across thing. And basically, if S1 and S3, for example, are literals, you would think that S1 and S3 were folded, but the compiler doesn't even do that.
Right.
It's only from
if S1 is
natively folding.
non-literal, then folding is turned off because the tree is weighted to the left.
Yeah, which to me is also, I mean, the problem in practice is like if you find code like that, I'm not sure that code is meant to be efficient, right? I mean, single concatenation isn't very efficient to begin with, right? And so now if you rewrite that thing to something that is in principle more efficient, like is the overall thing, I mean, I kind of doubted that it's still, because I mean, you're basically building large strings, right? And that problem doesn't seem to be something that is super worth optimizing for, because it's generally never going to be very efficient.
I mean, most programs are just string concatenation and symbols. So,
well, I mean, depending on what you're doing, but I mean, I'm just saying, like, I mean, if you write code like that, right, meaning like A plus B plus C, right, that's not code that will be very efficient, right? If you build like something like a Razor view engine, sure, it's string concatenation, but you don't find A plus B plus C plus D in the implementation, right? Like, it will look extremely different from that. That's kind of my point.
Yeah, it'll be string.format.
Well, it will be more like, you know, multiple buffers with holds, and you don't actually see the, you know, it's all kind of generated trees or whatever, right? So I think the question is really like, if we ship this analyzer, right? Like, are we doing the user a service or a disservice?
Do we have like a tier of analyzer? So maybe someone can say, I always want to enable this thing because 99% of the time it gives me a good recommendation, whereas something like this, maybe we can say, put it in the next tier of like, you're looking for some optimization, and 20% of the time it'll give you something really useful.
We don't really. We basically have two pivots. We've got category, and there's a performance category, part of that, and then there's just severity level. And so it basically, what you just described would basically be the rule is off by default, and then you go and you turn on the ones that you care about. I don't believe there's any way today to kind of have predefined groups of analyzers. You know, like, this is you're bored on a Saturday afternoon and you want to go explore what you can improve category.
Well, I think that's you go to editor config and you say turn everything on and then see what happens.
Right. Performance warning. That's too noisy. I'm gonna go outside instead.
I mean, this is kind of my meta question. It's like, I kind of agree with like what Jeremy said earlier. It's like, if the analyzer actually gives me this particular fix, I would be unhappy. Maybe there's other here that I don't mind, but this particular one that is right now in the middle of the screen seems not great.
Yeah. Like, as with, you know, many things, if this was in code that had not changed in 20 years and you anticipate no change ever again, then yes, this is arguably better. But, you know, if it's code that ever stands or ever needs to be debugged or ever stands a chance of changing, this is code that expresses its intent, and this is code that runs faster. And so, yeah, I would not put this fix, which is maybe just a line length and style thing, and this in the same bucket.
Yeah, I think the conditional one would also need to have some sort of heuristic of at what point will a string builder save you? Because right now, if you're just making one concat, then maybe a string builder would not be an appropriate choice here.
Mm-hmm.
I really want to make a string builder. Did I mention that?
Well, and with string builder, if you have a lot of non-string inputs like ints, like you're doing int.toString, then string builder itself uses the span formatable overloads to try and write directly to its internal char buffer, whereas string concat just calls toString, gets the length of that, and says this is how big the total buffer needs to be.
Yeah.
We should probably
Sounds like we're
look.
saying this needs work.
Yeah, I think also to what Tanner just said, like the fact that there's a difference in how the formatting, the efficiency of the formatting between string concat and string builder, like is also probably something as an implementation detail we should look at. There's no reason. Well, I guess there is a reason. String builder.append has strongly typed overloads that take int, double, etc., and those are the ones that use the span formatable. If you just give it an object, it doesn't use it.
But it can once we add the interface that Tanner needed for generic math, the ispan formatable thing.
Well, that's already in.
Oh.
But the question is, do we pay the cost for an arbitrary object of the type check?
Type check's
maybe
probably cheaper than throwing the string away.
Yeah, I mean we're inconsistent. So.
Yeah. Okay. We seem to have an unhappy feeling here, but I don't know what to write down.
I mean, to me, the argument would be, I'm not sure that the resulting code is better. Like it seems, it might be faster, but even that seems speculative based on what we just discussed with the differences in formatting.
I think
then
the
there's
problem
also
is that, Sorry, go ahead.
Yeah.
Go ahead, Timo.
No, I mean, and then there's just the other side of like, is the code more readable, right? Like if you actually duplicate expressions, that's generally not a great outcome, even if performance is slightly faster. It's like, it seems you're pushing people down the wrong path.
I mean, it really depends, and that's part of the problem here is there are so many gray areas here that there are some things that are obvious, but it might be hard for a rule to detect, obvious to us. And then there are other things that are it's the eye of the beholder. Like we have a bunch of cases where you're allocated. It's not S1, S2, ... Sn. It's a conditional with it's either S1 plus S2 or it's S1 plus colon plus S2, right? And that's very easy to read in that form, and so it makes sense to do that change. It's arguably easier to read that than string result equals S1 if needs conditional plus equals colon then plus equals S2. But the moment you get into more complicated things, or those are large expressions or whatever, then it becomes hard to read. So this is all very difficult for an analyzer to determine with high accuracy whether the developer will appreciate it or not.
Yeah, it's also like if you're sensitive to perf, I mean, you kind of know if you write super big expressions with a plus b plus c plus d that you probably need to rethink your problem. Like it's usually not a way. The problem is usually not the way you write it, right? It's the fact that you do concatenate these multiple strings might not be the right answer. And that's something that analyzer can't help you with, right? That's just rethinking your data structure, maybe not needing the strings in the first place.
That's true. At the same time, it's again degrees. Do you not optimize it at all because you couldn't go all the way, or is it better to eliminate half your allocation?
Yeah, I guess that's fair too.
Yeah, I mean I can get behind the unconditional, non-inspected concatenation. Like that seems like a reasonable thing to do. It's all the rest of the stuff that I find questionable. So I don't know if it's
my question
break this
is
into
like,
multiple things or what.
I think
guess
that's
my question is, are there some cases here where the compiler just can do it anyways? Like, I mean, the unconditional one where you split things into two lines, why can't the compiler do that themselves?
I'm sure Jared would say it's not the compiler's problem, but
sure. But if you introduce a local and then the only thing you do with it is concatenate onto it, like that seems like a fairly trivial optimization at that point.
Unless you're in a debug build, in which case,
yeah, but who cares
F10
about
needs to matter.
Debug build?
Indeed.
Yeah. Like
All right.
if you measure your performance throughput of your debug builds, then maybe your performance has other problems.
Indeed.
I think the next steps here are for someone, if we care, to split apart the one that we feel like, is there something that is non-controversial from the rest of it, and then focus on the non-controversial parts. And if we
who
can't
brought
find
this up?
anything, I probably did it initially.
Okay. Because I mean, like the problem with these one-liners is that there's not. I guess we had some sample code in here.
Yeah, so the conditional one was in the original description.
Okay. Yeah.
All right, so
or we just turn this down and be like, yeah, this isn't worth it. It's not like we're going to get to all these.
Yeah, I guess the question is did this show up at some user code, right?
Oh, this shows up in our own code.
Yeah, I see this all the time.
Oh, really? Okay.
Yeah.
You guys are terrible.
all right.
Yeah.
So yeah, am I hitting close or needs work?
I mean, if we find it enough in our own code, then maybe it's worthwhile taking another look. If we think it's super fringy, then close and move on.
Keep it open. Let's take another look. One more try.
One more try.
All right.
Carlos.
Since Carlos is the one who has the action item of dealing with needs work.
Yeah. Any volunteers?
I volunteer as tribute. Yeah.
Override stream read byte and write byte 33788.
Oh yeah.
You're a stream and you didn't override these members. You should do so.
Why?
Because they're hideously inefficient.
But
We have-
I mean, does anyone actually use these APIs?
Oh yeah, they're used by things like binary reader under the covers, because they need to do a byte by byte read from the underlying stream.
Yeah,
Okay.
it's if you're an intermediate thing, then you can't. And read ahead is bad because you can't unread a stream.
Yeah, the flip side, the other thing we've been hesitant to do, but we could consider doing, is change read byte and write byte to delegate to the span-based read. We've been hesitant because anytime we change order of virtual delegation, it potentially causes issues. But the main problem with these today is they allocate every call in the base implementation is new byte 1, and then call the array-based method. If we were to just delegate to the span-based one and the stream properly implemented that, then we wouldn't have to do that.
What if you change it to do the same thing the span write method does, just rent, write, return?
You mean change the base implementation to do that?
Yeah, of write byte specifically. So it still calls write, just with a rented array.
I mean, you're still not getting the benefit if the method has actually implemented the span-based one well.
Mm-hmm.
The rent, call the array one, and return is still way more costly.
Mm-hmm.
But we could, as a stopgap, we could choose to. I actually don't know what's going to be more expensive. I mean, array pool isn't free, and
I was
you'd be renting a
gonna say
we could use TLS instead of array pool like that. We have options.
I was gonna say have a lazy initialized field for the single byte read and the single byte write.
Yeah, but then you're increasing the size of stream for everyone.
Fair enough.
But if you use TLS, you're not increasing the size of stream for everyone.
Right. We've discussed the TLS thing in the past, and I'd raised concerns around recursion. If it's on the base stream, then it's not just renting it. It's not just using it, but you take it out and you null it out, and then you call to another stream which isn't unheard of. Like stream read byte delegates to another stream's read byte, and it tries to get the array, and then you're back into the world of allocating because it couldn't find it.
True, you've prevented one allocation,
Yeah.
but you're saying that recursion might be frequent enough where it's not a winning proposition.
That's my concern, just because wrapping streams are common. That said, maybe I'm wrong. And that's certainly possible.
It almost feels like there's something wrong if we're forcing people to actually use read byte and write byte, because we already know that these are inefficient if they actually perform I/O.
It's not that it's wrong per se. Sometimes it's necessary in the sense that again, I go back to the binary reader example. Like I'm reading data from the wire. Like I need to read I need to read like a 7-bit encoded integer. Like I can't risk reading ahead, because as soon as I've read a byte off of the wire, like I can't go back and unread it. That might not belong to me. Like it might belong to someone else.
Yeah, I mean,
and now I've corrupted their data.
We could say that all callers are supposed to themselves do, span of 1 into the span read, but that would basically be saying that we mark read byte and write byte as obsolete.
Yeah, I think the problem in general is like, I mean, it's also a generic problem, right? It's this thing we discussed earlier where, because the way we have to add virtuals later, there will be cases where you kind of have to override them in order to not have a shitty implementation.
Yeah, I mean, I guess the answer is if you're because Net Standard 2.0 stream doesn't have the span or memory versions, right? It can't.
Correct.
Yeah.
So, especially if you're Net Standard 2.0, it's, hey, you might be able to do something way fancier here than we can, because we can't even see if you're in a potentially more interesting universe. So I think it's reasonable to have a performance analyzer that's like, hey, these methods, if they get called by somebody who uses your stream, which is not a thing you control, unless you're an internal class, they show up on a lot of people's perf traces. So performance info, hey, you should override these methods, seems reasonable to me.
Yeah. Do we have a more general analyzer just saying you should try to overload all the stuff on stream? Because this seems like usually you want to overload pretty much everything on stream, right?
We had talked about this in the past, hadn't we? Like, didn't we talk about, like, there are certain types that even if methods aren't marked abstract, like, you really should override them?
I linked the related issue in my comment at the top. It could be part of it. Sorry, not at the top, at the top of my comment. Yeah.
Wow, Asyncresult. Yeah, I mean, this one seems this is a little different, because it's talking about the old async pattern, and it's saying if you wrote the old async pattern, you should at least move up to the new async pattern. But the span and memory ones then are harder because, again, Net Standard 2.0.
I mean, I think that's generally the right idea, though, because I feel like when you derive from a type, overriding everything, it might not be necessary, right? If you, for example, implement a stream that can only read, I never care about writes. So why would I get flagged to override all the write methods, right? That seems backwards. So you would have to have at least some smartness that says, well, if you override this one, then you should also override that one, right? But the problem is I feel like the Swiss Army knife.
Something is abstract, and then the analyzer would have to be doing the, like, did you implement it as something other than unconditional throw? But
yeah, in fairness, that wouldn't be that hard, but yeah.
Yeah.
I mean, the other example is stream reader, right? Oh, sorry, text reader, right? Or text writer. I forgot one of them that basically, yeah, I think it's text writer, where everything is by default. The only thing you must override is the one that outputs a char, and because everything else calls to that one, which is a valid implementation, but extremely inefficient. So if you really want an efficient version of that, you should override all the methods, not just the one that outputs a single char. And that's kind of in the same category, right?
I think this is fine. It's a perf improvement. I just suspect many people implementing streams probably don't care about these, but I could be wrong.
I think the biggest problem with Stream is getting an implementation that works is already hard enough, right? So it's
yeah, it's
like, I
kind
mean,
of like a profiling exercise, because most people, like, not talking about, pipe reader stream, which I mentioned in chat, doesn't implement this, but most people are not creating like general purpose streams, right? They're just creating it for use with like one API or whatever, and they want
Yeah.
the minimal thing that works.
I mean,
I'm
this
just
is what
looking.
we said. I mean, we said many times you really want a delegating stream, right? Because it seems most people want to just basically intercept something like, okay, how many bytes were read or how many bytes were written for some reason or something, like as simple as that, right?
Yeah, but the
And
trouble, Stefan, with like, great, you made a stream to interact with one API, is you don't know what that API is calling. If it's calling read byte and you could have made a more efficient read byte, then you definitely wanted to override it if you care about performance.
That's why I
If
say
you
it's a profiling exercise,
fair enough.
right? Like,
Yeah.
I would look at it or just look at the code before writing out all these methods. Like, I would not blindly, and like, unless the analyzer is writing these methods for me somehow, but how would it? Like, because, unless it's doing like the default implementation, doing up arrays, like.
yeah, that is the problem.
I was just looking at pipe reader stream. It basically makes no effort to make any of the synchronous APIs work efficiently. It's entirely focused on the async ones, so it's not really surprised that read byte wasn't optimized.
Right. Yeah. I mean, and that's how all of ASP.NET streams are in general.
Yeah.
Because ultimately, due to our abstractions, it's going to be sync over async anyway if you go that route. So it's already in a really bad place.
But don't you throw anyway? I thought you throw when somebody does a synchronous read on
So we
anything.
will. You can turn that off for legacy code, but yeah, by default.
I see. That probably is why you never cared, yeah.
Right.
It's functional,
similar
but
with
not
pipes,
not
right?
efficient.
Yeah.
And with pipes, at least if you're building off a default pipe and you're not like, wrapping a pipe that's wrapping a stream, like, it's going to be sync over async again, for the most part. So anyway, I'm filing an issue though to override these for the pipe things.
I mean, I think, as I said before, like, I think we probably should revisit stream. Like, it seems like deriving from it is just really, really difficult. And like we said before, we would like to have a delegating stream, which could simplify some of the stuff quite a bit. And then you're basically just left with the super experts, like, the people that have to implement pipe stream, for example, right? And for those people, I'm not sure the analyzer is helping you that much. But if for the ordinary customer, maybe they shouldn't derive from stream to begin with. They should just.
I mean, we can
something
certainly throw something in System.io like Stream 2021 or span focused stream or something that inverts
bring
all
the
of the
EX
relationships of
suffix back.
things, and is the, if you're making a new stream, this is the stream to override, because now we have, the considering span and task likes to be the primitives and rewriting everything else in terms of those, the way that we do in all of our higher level streams, and then just insert this as your new base class instead of stream directly, and ta-da, life got simpler for you. We could do that. It doesn't help in a lot of cases like this.
No, that's why I'm saying it would be worthwhile, like, figuring out what the scenarios are that people want to go for, and then ask ourselves, is that just a case of a missing base type, or is that just something where we should have a better analyzer that helps people to do these things? Because I mean, like, basically my concern is deriving from stream is super difficult today, right? It just is, right? And I feel like this is just an example where, yeah, you should probably do that, but then at that point, they already have to deal with, like, I don't know, 10, 15 different methods they need to override. You're throwing 2 more on top of that stack. Is that resulting in better code or not, right? Because I mean, the code still has to work, right? And I mean, read byte and write byte might be inefficient, but at least they work, right? Versus on text reader, or was it text write or whatever, where the implementations are kind of obvious. It's not super difficult to implement them, right? But on stream, depending on what you do, it might actually be fairly difficult to do these things. And that kind of goes back to what do people want to do with that, right? If they want to do something trivial, then maybe we should just let them do the trivial thing and not ask them to override 20 methods.
Well, I'm not sure the comparison to text reader, text writer plays out. I mean, it has the same problem. It's got like 40 bazillion virtual methods, any of which you can override. And if you don't, you get the inefficient things. The same on stream. You override read and write, and all your read and write methods work. They're just not nearly as efficient as they could be.
No, that's what I'm saying. To me, yes, I think it is the same problem. I'm just saying on stream writer, or sorry, text writer, you at least have the ability, like implementing those is relatively trivial because they're all sync methods. You know, they all take basically an int or a float or whatever, and then most of the time, whatever your underlying thing is, has an ability to write those already. But on stream, the problem is you have different, you have the old async model, you have the new async model, you have value tasks. So implementing those might not be very trivial, right? And so like the more methods you throw at the person, the harder it is for them to get something out that actually works, right?
Right. Like I said, so we could make, stream 2021, because coming up with a name of why it's the better stream, in 5 years we'll have a new primitive that we wish we'd base stream off of, and that it implements all of the methods in terms of the span-based read and the memory-based read async, and it makes those as abstract read core and read async core, and great, override that, implement these 2 members, everything else was declared sealed, and you're done. Like, you now have what did you actually have to write? Oh, I think you also need to do can read and can. You need to do the can things and the seeks, but just make it default to non-seekable, and now you're done. But that's a thing that we would rat hole on for 4 hours in a design review meeting. So.
Yeah, I'm not saying it's easier. I'm just saying it might be better for the user.
Sure.
And I mean, we have talked about delegating stream at link several times. We've never really designed it, and that might be a better first step than the analyzer, right? Because then, as we're just doing that, we might actually take a deep enough look to even understand, like, okay, maybe there is a general analyzer that we want to have, or maybe there isn't, right? Maybe it's just let's fix the API shape as much as we can.
All right. So, I mean, it sounds like there's either 2 easy answers for this. One is it's a reasonable info performance suggestion, and the other is overriding stream is already hard enough. This analyzer just reveals that complexity in a non-helpful way, and we want to say no to it. And I don't know which one the group is feeling.
The latter for me.
I think my problem is that in my experience, every time I see a derivative of stream, people don't do it because they do something fundamental. Usually it's just some hack or workaround or some testing stuff. So they don't care about perf. They just care about that it works, right? And then to Steven's point, they pass the implementation to one API, they throw from all the implementations, and then they fill in the gaps until it stops throwing, right? And then they call it a day. And at the end, if the framework implementation now starts calling different virtuals, well, too bad.
That's exactly it, Ema.
And I think that's kind of the way most people do it. And that's kind of why I don't think they would care that read byte, it's inefficient. I don't care. At least it works. And so I think that's kind of why I'm hesitant to say that we should have that on by default. But I still think the root cause really is that stream is too damn difficult to derive from. It should not be. And I'm wondering whether we can fix that, at least for some of the scenarios, right? We probably can't fix everything, but I like your idea of just, you know, a new base type that seals almost everything and then only has a few worker methods, and then we can reason about who's delegating to whom, right? And then you just tell people, like, derive from that guy, you have to implement 2 methods, and then that's it. The read side and the write side.
It seems almost like this analyzer could be really useful if paired with a profiler. So if we actually notice you calling read byte and write byte, then we pop this up.
I mean, I get that is true. I don't know. It feels like you'd need a special debug, or you'd need a special build that did override everything and call base just so you could see the fact that you called your stream dot read byte to show up in the profiler, because you wrote a stream and stream dot read byte got called. We don't know that your stream was the type at the time. I don't think. But I completely agree with that. If you have profiler data that says read byte is causing you a problem, and this says, you could probably override it and solve it, that would be great. So, all right, it sort of sounds like we want to say no.
Profiling, yeah, you know you can do this if you already see it in a profile. And I think long term, I love Emo's idea of like a delegating stream or whatever. So the tooltip would be switch your custom stream to that once it exists, and forget about all these like small little stream optimizations.
It's very hypothetical though, right? I mean, like, it's, we can, of course in our heads it all works out, right? But when we actually sit down and design it, we may not be able to ship it, right? So
I see this as fairly low value. Like, yes, this would have highlighted things in like, pipe reader stream and so forth. Customers aren't coming down our door. Like, we haven't gotten PRs to fix it yet. And people know how to use profiles. Like, they could see it. Like, if something's actually calling read byte, like, they could see it. Like, there are people in our community who are very concerned about perf. They're apparently not calling this API, at least.
Yeah.
All right. I say let's not do this.
I would agree with that. I would say, as notes, I would probably say we should look into deriving from stream in general. Maybe reviving the idea of delegating stream for some of the users, and then just say that the remaining bucket of people that actually cares about streams, they probably already profile, and they already go through so much trouble to get their stuff to work that they're probably either override these methods, or like ASP.NET, they don't care because nobody ever calls them.
All right, it is noted that button. All right, and since we only have 5 minutes left, I move we adjourn.
Agreed.
No easy ones.
I think we would have thought that any of these were easy, and we got through 3, 4 in an hour and a half. So
Yeah, I guess that's fair. All right, so then I guess
maybe the span clear one's easy. Famous last words, but
if you see span.fill 0, then call span.clear.
yeah.
Performance
Yeah.
info.
Yeah.
seems reasonable.
Look at that, less than 30 seconds.
That's a
Excellent.
record.
Come on, let's find one more.
Limited by my typing speed. Okay.
The second to last, maybe? Prevent wrong usage of string split.
Could take you more than 30 seconds to read this.
Yeah.
Oh yeah, this was the one where we were talking earlier about if you have an API that takes an int that takes an int parameter, and you pass a char that will be implicitly coerced into that parameter, you might be calling the API incorrectly. I think it was a general case of that, right?
That sounds right.
That sounds familiar. Yeah.
Yeah.
Basically, implicit conversions from char to int. I think
Across
might
an
be called
API
an-
boundary.
Yeah,
Yeah.
across an API boundary, it seems like a reasonable thing to flag in all cases. I'm gonna be fine.
Fair
False
enough,
positives with that.
I think we'll.
I think there is more to be said on that, though, because
Yeah.
I think we might want something generalized rather than just string.split.
So. Okay, having had a motion to close or adjourn, and it was seconded. And as the chair, I call the meeting to a close. So, see everyone regularly scheduled time, Tuesday, 10 a.m. Redmond time, where we will be back on the general backlog in the order that they got proposed. And as all these things are marked future, we'll get back to it at some point that Emo thinks is appropriate.